We're going to talk about physics and motion using logic blocks. I'm going to start out here with a brand new fresh file. When you press P for play, that brings up the game engine, and that will apply physics to the objects and cause certain things to happen, like gravity causing the objects to fall. But you have to do a few things first in order for that to happen. If I select a cube here and go over to the Physics Properties tab, which is the little moon orbiting the planet, I can actually change the physics type of the cube to from static to rigid body. So then if I press play, we'll see that the cube falls as gravity is applied to it. There's a few different options here. Rigid body is probably the most detailed. It's also the most computationally intensive physics type. Dynamic physics is a little bit simpler. So if you notice that your game is slowing down, for example, you might try switching to dynamic physics. Character physics is also another simplified physics type, and it has some additional options here which may be useful when you're programming your character. In order to demonstrate the physics, I'm going to add a new plane on here. So we have a ground for our cube to land on. So I'm going to press Shift A and go to Mesh and Plane. And then I'm going to press S and 10 and enter. And that will scale my plane up by a factor of 10. So the plane starts out as 2 by 2 meters. 2 by 2 times 10, it becomes 20 by 20. If I select the cube, I can press G for grab, Z and 2, which will move my cube up 2 meters. If I turn on the viewport shading up here, you can see the shadows and kind of see what's going on there. So now if I press play, you'll see the cube falls to the ground. I'm going to move this cube up a little bit further. I'm going to press GZ3, move it 5 meters up in the air. And what I'm going to do is I'm going to add Shift a cone here to kind of demonstrate some of the different physics. I'm going to press GZ1 to move that up. And I'm going to press G and X. I'm going to slide it a little bit forward. So when I press play, this cube has a physics type. I'm going to change this to rigid body. When I press play, you'll see the cube kind of rolls off the cone, and then it has a very unnatural movement. It actually rolls completely off the plane. And that has to do with the collision type for this cube. By default, the collision type for any object is a sphere that's defined by its radius attribute, which is located here under physics properties. If you want a more realistic physics collision model, you could go down to collision bounds and click that check mark. And you can actually select different types of collision bounds. If you have a sphere might be more appropriate, a cylinder might be more appropriate for a cylinder collision, so on and so forth. So now if I press play, you'll see the cube rolls off the cone and then lands flat on the plane. Escape out of play mode. But what I want to show you is kind of some of the differences of the physics types. So if I go to dynamic physics, I said dynamic physics was a little bit simpler and a little less process intensive. But if I press play here, watch what happens to the cube. So it's no longer going to roll off the cone like it did previously. The physics have been simplified. The same is going to be true for character physics as well. So although there's some advantages to these physics types, less processing power, and with character physics, you could change things like multiple jumps very, very easily. It does come with some trade-offs. So let's start adding some logic to make these objects move. I'm going to get rid of my cone by pressing X and then delete. I'm going to shove my cube back by pressing GX -5. So it's kind of sitting there at the back of my plane now. And what I'm going to do is I'm going to drag this editor up down here on the bottom. Let me zoom out a little bit so you can kind of see what's going on. Now I'm going to change the editor down here. By default, the editor is set to the timeline. I can change the editor by clicking on this drop down here and going over to Logic Bricks Editor. Now, logic is divided into 3 separate blocks. We have sensor blocks that allow us to detect input. We have controllers that allow us to add logic. And then we have actuators, which allow us to affect or make certain actions occur. So let's add a keyboard input, keyboard sensor. You can name the sensor blocks up here, and I encourage you to do that because it'll make it a lot easier to see which blocks are which. So I could call this keyboard W, for example. And if I minimize this by clicking the little caret here, you'll see what that looks like. But just putting the key up here does not define the action we're looking for. In order to do that, we actually have to click on this block right here. So it says press a key and then press W. So when W is pressed, I want to do motion. And I want to move the object forward. Now forward for this object is going to be in the X direction. So I'm going to change X location to 0.2, let's say. There's 2 types of motion here by default for simple motion. You can actually change this to character motion, and we'll go over that in a little bit. But under simple motion, we have location, which allows us to move an object in the X, Y, or Z direction, and rotation, which allows us to turn the object, which we'll look at in a little bit. This L over here allows you to specify whether the motion is going to be local, that is relevant to the object, or a global motion that's relative to the entire scene. There may be advantages in both approaches. It kind of depends on your situation and what works best for you. Usually I stick with local motion as much as possible. So then what we need to do is we need to connect these all together with a controller. The default controller is an AND controller. So in order to connect these, I'm going to draw a line from my sensor to my controller, linking the chains up here. And then I'm going to draw a line from my controller to my actuator. I'm going to name my actuator, I'm going to call this forward. So when my W key is pressed, I'm going to activate the forward motion actuator. Excuse me. So if I click play and W, my cube moves forward. Let's add some turning. So I'm going to add another keyboard input. And let's do this for A. If A is pressed, at our default controller, I want to do a simple motion, and I want to spin on the Z axis. I want to go, let's say, 3 degrees in the positive direction. And this is going to be counterclockwise motion. So I'm going to name my block CCW for counterclockwise. I'm going to link these together, A to my sensor to my controller, and my controller to my actuator. Press A, or press P for play. I can move forward, pressing W, and I can turn counterclockwise by pressing the A key. Escape out of that. We can go ahead and do that in the other direction as well. So for D, and remember, putting the name up here does not define the key. We actually have to press the block down here to define the key. I'm going to add another default controller, and I'm going to add another motion actuator. I'm going to rotate in the clockwise direction. And if positive 3 degrees is counterclockwise, and negative 3 degrees along the z-axis is going to be clockwise. Connect these together. Minimize, minimize. So keyboard D gives me clockwise motion. So if I press P for play, move forward, turn this way, turn in place, right off the edge. Woo! Alright. One final thing I'm going to do is I'm going to add some jump motion, and really the easiest way to do that is with character physics. So if I add a keyboard sensor for space, name that space, and then click the space, I can drag down by clicking the scroll wheel. So if you look down at the bottom here, it kind of gives you hints for what the different mouse buttons do. And pressing the scroll wheel will allow you to move the logic bricks around. I can add my AND controller here, and I can add some motion here. Now for my jump motion, which I'm going to call this jump, I actually want to change the motion type to character motion. And scroll down, and I could toggle this jump here. And what this will do is it will activate the jump motion for the cube, but it's going to use the attributes defined in my game physics, since I'm using character type physics, to determine the jump physics. So if I press play now, I can jump and jump, I can jump. I can increase the fall speed if I want him to fall faster, or decrease it if I want him to fall slower. I can increase the jump force if I want him to jump higher. I can even increase the number of jumps if I want to be able to double jump. I can set max jumps to 2. So now when I move, I can jump, jump, right off the edge. Step height determines basically how high a stair step can be for the cube to be able to climb the stair without jumping up. So if you ever played Minecraft, older versions of Minecraft, you had to kind of jump up every 1 block step, whereas newer versions of Minecraft, some newer versions of Minecraft had the ability of you could just walk up the 1 block height difference. That was because they increased basically the step height for the character. By default, it's set to a step height of 0.15. So any step that is, what is that, 150, no, 15 centimeters? The cube or the character will be able to climb that step just by pressing forward without having to jump up. And then max slope down here determines the maximum slope that a character can climb. So by default that's set to 90 degrees, which means basically that the character can't climb up the walls. But if slope is 89 degrees, for instance, your character would be able to climb up that slope. So you can play around with that and find out what's going to work best for you. Alright, I believe That covers everything for physics and basic motion. We have our forward, counterclockwise, and clockwise motions. We have our jump motion, and we talked about static, dynamic, rigid, and character physics. Thanks for watching, and happy blending.